In this video, we're going to graph the curve y equals 1 over x squared plus 4x. Well, in order to graph the curve y equals 1 over x squared plus 4x, we'll begin by graphing y equals x squared plus 4x. To determine the x-intercepts, we'll let x squared plus 4x equal 0. Meaning x will be either equal to 0 or negative 4. We have an axis of symmetry at halfway in between those two numbers, 0 plus negative 4 over 2, which is negative 2. And we can determine the y value of that axis of symmetry. And the y value will be equal to negative 4. So we're going to have a vertex at negative 2, negative 4. So we'll sketch a parabola with that vertex and x-intercepts at 0 and negative 4, and it'll look like that. Now, the first step in our process will be to draw a vertical asymptote at every x-intercept. Well, one of the x-intercepts is at 0, so we'll use the y-axis as our vertical asymptote, and the other one's at x equals negative 4. Our next step will be to indicate each point where the y value, each point on that curve where the y value is either equal to 1 or to negative 1. And there they are. And now we're going to treat the asymptotes like asymptotes. And so in this first interval, in the first region of the curve in the upper left, that's fairly easy to do. Treating those asymptotes like asymptotes, we go into the vertical asymptote of x equals 0 and into the vertical asymptote of x equals negative 4, using the y-axis as a horizontal asymptote. Now, in between, we've got this interesting region in the middle underneath the x-axis. So we have a vertical asymptote, and as this curve goes up to the left from the y value of 1 up to the x-axis, the 1 over f of x curve is going to go down to the left. And so we're going to be tracing along our x-axis. We're going to be using that vertical asymptote as a guide. Same thing's going to happen on the other side. Okay. Now, in the middle, we see on our original curve, we have a vertex at negative 2, negative 4. So we can say that the curve y equals x squared plus 4x has a minimum at negative 2, negative 4. Well, if I use the reciprocal function of 1 over x squared plus 4x, then we know that as x squared plus 4x gets bigger, 1 over x squared plus 4x gets smaller and vice versa. So that changes the word minimum to the word maximum. Our x value of negative 2 stays the same, but now our y value is 1 over negative 4. So what we want to do is we want to go to the point negative 2, negative 1 over 4, right about where I drew it there. And we want to draw our curve. We want to draw our curve to go through that point and then back down again. So that point where x is negative 2, that should serve as a maximum. And so now we have the curve drawn as we wanted it to be. Well, our domain is going to be the set of all x element of the reals, and our range is going to be the set of all y element of the reals, such that y is less than or equal to negative a quarter. That's the bottom part underneath the x-axis. And y can be greater than 0. And that's the top two parts in unison. Now notice there is a portion of the y values that aren't included in the domain, and they're right here, sort of where the little red dot is. Right in there, that there's an empty space in terms of y coordinates. You can't have a y value in that interval. So you need to make sure your range indicates that. Now, for increasing intervals, we see that we can say x is an element of the interval between negative infinity and negative 4 in union with the interval between negative 4 and negative 2, because negative 2 is the x value of our maximum point. Now, there's a way of thinking which I actually adhere to as well, which says that we should put a square bracket on that negative 2, because the negative 2 is included in the increasing interval. Your textbook uses a round bracket though, so in terms of the negative 2 there, I'd accept it either way. Now your decreasing intervals, we can say x is an element of the interval between negative 2 and 0 in union with the interval between 0 and infinity. Or like I said, we can put a square bracket around that negative 2 and refer to this as our decreasing interval. Our positive intervals, that means any part of the curve that's above the x-axis, well, that's when x is in the interval from negative infinity to negative 4 in union with the interval between 0 and infinity. Our negative interval, that will be when x is in the element, when x is an element of the interval from negative 4 to 0. And finally, our horizontal asymptote is at y equals 0, and our vertical asymptotes are at x equals 0 and x equals negative 4.